Hi everyone! Today we'll be looking at how to find angle measures using trig ratios. Here's today's FLT. Given a right triangle, I will be able to find missing angle measures by applying trig ratios. Before we get to the main topic of the lesson, let's quickly look at some inverse operations. An inverse operation is basically an operation that reverses the effect of another operation. For example, let's say we have x plus 3 equals 8 and we have to solve for x. In order to isolate x, we need to remove the plus 3. We do this by applying the inverse operation. We subtract 3 on both sides. And then we're able to solve that x equals 5 by using the idea of inverse operations. Another quick example, let's say we have 7x equals 28. That's the same thing as 7 times x equals 28, right? So to isolate the x, we do the inverse operation. We divide by 7 on both sides. And x equals 4. So in this case, multiplication and division are inverse operations of each other. So we just looked at these two inverse operations, addition and subtraction, multiplication and division. The trig functions also have inverse functions. So sine and sine inverse are inverse operations. So if you want to get rid of sine, just use the inverse operation, sine inverse. There's also cosine and cosine inverse, as well as tangent and tangent inverse. So let's see how we can use inverse operations on trig ratios to help us solve for missing angle measures. Just as a reminder, when we're working with right triangles, the opposite and adjacent sides depend on where you're standing. The opposite side is on the opposite side of where you're standing, whereas the adjacent side is the side next to you. Lastly, the hypotenuse is always across from the right angle. We've been using SOHCAHTOA to help us remember trig ratios. So for example, sine of theta equals the opposite side over the hypotenuse. And cosine of theta equals the adjacent side over the hypotenuse. Lastly, tangent of theta equals the opposite side over the adjacent side. Today we're just working with these three trig ratios, so we're not working with the other three today. So here's our first example for today. Find the measure of angle A to the nearest tenth of a degree. Make sure to draw out the triangle on your notes as well. So we've used trig ratios to find missing sides. Today we're going to find missing angle measures. Here we're going to find the value of angle measure A. So similar to previous lessons, go ahead and place your person, penguin, whatever, at angle A. From angle A, let's identify the given sides. We're given the side length of the opposite side right here, side BC. So this is the opposite side. And we're also given the hypotenuse. Remember, the hypotenuse is always across from the right angle. So which trig function can we use here? Which trig ratio involves both the opposite side and the hypotenuse? Notice for this example, we're ignoring the adjacent side since it's not given. So we're just focusing on the opposite side and the hypotenuse. We can use the trig ratio for the sine function. So sine of x degrees equals the opposite side over the hypotenuse. In this case, the opposite side is 16 and the hypotenuse is 73. Right here, make sure you're writing them in the correct order. So I have that sine of x degrees equals 16 over 73. I want to solve for this angle measure x, but the sine is in the way. So how can I get rid of this? I can do inverse operations. So I can apply sine inverse on both sides of the function. So sine inverse of sine of x degrees equals sine inverse, remember you want to do it to both sides, of 16 over 73. This part cancels out because they're inverses of each other. And so we're left with x equals sine inverse of 16 over 73. And from here, to solve for the actual value of x, we're going to use our calculators. So go ahead and pull out your phone calculator or use a calculator online like the Desmos calculator or the Delta Math calculator. So if you have an iPhone, make sure the top left is blank. You don't want it to say rad. Remember, we want it in degree mode, so it should be a blank screen. We want to go backwards. So 16 divided by 73 equals, and then to find sine inverse, go ahead and click on second, and then click on sine inverse. So go ahead and practice this a few times. Make sure you're getting the same answer as the one presented on the screen. Now, what if you're using an online calculator like the one on Delta Math or Desmos? This one's the Desmos calculator, by the way. So if you go to functions, there's the sine inverse, and then you're going to type 16 and then divided by 73. So remember, when you're using calculators like the Desmos calculator, you just type it literally like it's presented in the example. So back to our example, we found that x equals 12.6607, and then kept going. But remember, we're going to be rounding to the nearest tenth of a degree. So that means x is approximately, 12.7 degrees, because we're rounding again to the nearest tenth of a degree. And so this is basically telling us that the measure of angle A is approximately 12.7 degrees. We were able to use trig ratios to find the measure of angle A. Let's look at another example here. Again, make sure you're drawing the triangle in your notes. Here we're going to find the measure of angle C to the nearest tenth of a degree. So we're going to be standing here at angle C, and we're given the opposite side as 2.1, and we're also given the adjacent side, the side right next to us, and the value is 5.3. Notice here, we're not given the hypotenuse. So which trig ratio can we use here? Tangent. So tangent of x degrees equals the opposite side over the adjacent side. We know the opposite side measures 2.1 and the adjacent side is 5.3. So 2.1 over 5.3. Again, make sure you're correctly ordering these ratios. To isolate x, we're going to apply the inverse operation. So we're going to apply tangent inverse to both sides of this function. So the tangent inverse of tangent of x degrees equals the tangent inverse of 2.1 over 5.3. This part will cancel out because they are inverse operations of each other, and we're left with x equals tangent inverse of 2.1 over 5.3. So let's use our calculators. On the iPhone, remember you want to go backwards, so it's 2.1 divided by 5.3 equals, and then go ahead and click on second to find tangent inverse. And you get this, 21.614, and it keeps going. And if you're using the Desmos calculator, again, you're going to click on functions, find tangent inverse, and then just type in 2.1 over 5.3. We get the same answer, 21.6 something something. So using the calculator, we just found a value for x. X equals 21.614, and it keeps going. But remember, we're just rounding to the nearest tenth of a degree. So x is approximately 21.6 degrees. So we solved that the measure of angle C is approximately 21.6 degrees. Here we used a different trig ratio. We used the tangent function instead of the sine function. For example 3, we're going to find the measure of angle K to the nearest tenth of a degree. Try walking through this example on your own, and then press play when you want to compare answers. So here we're going to find the measure of angle K, which is this angle right here. So let me make sure my penguin sits here. And based off of standing there, we're given two sides. We're given the opposite side, right here, and we're also given the hypotenuse. So which trig function can we use here? We're going to use the sine function. So sine of x degrees equals the opposite side, which is 4, and the hypotenuse, which is 7. We're going to take the sine inverse of both sides to get rid of that extra sign. We get x equals the sine inverse of 4 over 7. And go ahead and plug this into your calculator if you haven't done so already, and then again press play when you're ready. So you should have gotten the same answer regardless of whether you're using your phone or an online calculator. X equals 34.849, and then it just keeps going from here. And since we're rounding to the nearest tenth of a degree, we get that x is approximately 34.8 degrees. So our measure of angle K is approximately 34.8 degrees. And let's look at one last example for today. We're going to find the measure of angle Q to the nearest tenth of a degree. This angle right here. So let me bring my penguin. Here, based on where the penguin is sitting, which two sides are given to us? Here we're given the adjacent side, the side right next to us, as well as the hypotenuse. This is the side across from the right angle. Based off of this information, which trig function are we going to use here? We're going to use the cosine function. So cosine of x degrees equals the adjacent side, 35, over the hypotenuse, 67. And then we're going to apply cosine inverse to both sides. So we get that x equals cosine inverse of 35 over 67. And Then go ahead and plug this into your calculator and see what you get. Press play when you're ready. So hopefully you got x equals 58.507, and then it keeps going. We're rounding to the nearest tenth of a degree, so x is approximately 58.5 degrees. So the measure of angle Q is approximately 58.5 degrees. In all of these examples, it's important to remember which angle you're standing at and then correctly identifying the given sides. Are you given an opposite side, an adjacent side, or the hypotenuse? After that, make sure you're correctly plugging in the inverse function into your calculator. So just as a quick summary, you can set up trig ratios to find missing angle measures. And then you can use inverse functions, such as sine inverse, to help isolate the angle measure. So we used sine inverse and other inverse functions to help isolate the x in our examples. Awesome job today, and please remember to submit your notes on Canvas. Thank you.